This is the solution to number 64 from section 6.2. And in this problem, we're trying to find the height of a mountain. And it says, in traveling across flat land, you notice a mountain directly in front of you. And then its angle of elevation to the peak is 3.5 degrees. After you drive 13 miles closer to the mountain, the angle of elevation is 9 degrees. And we're supposed to find the height of the mountain. So in this problem, we're given a diagram, and we're going to create two right triangles. So I'm drawing one right triangle in blue where we have a 9-degree angle of elevation, and then I'm going to draw a larger right triangle in red, and here we have an angle of elevation of 3.5 degrees. From each of these right triangles, we can set up an equation. We're going to use tangent in this case, because we want to find the height of the mountain, and the height of the mountain I'm going to label x on this side. We want to use tangent because we want to know the opposite side and we know something about the adjacent side. I'm going to label the horizontal segment, which is unknown, y. And so I'm going to put y here. And now I'm going to set up two trig ratios, or two equations using trig ratios, I should say. So from the blue triangle, we can say that tangent of 9 degrees, tangent is opposite over adjacent, is going to be x over y. And from the red triangle, I can say tangent of 3.5 degrees is x over 13 plus y. And now we have a system that we need to solve. So I'm going to take the equation on the left and I'm going to solve this for x. So I'm going to multiply both sides by y. And when I do that, I'm going to get x equals y tangent 9 degrees. And I'm going to substitute that expression in for x in my other equation, which is going to give me an equation in one unknown, which is just y. So that's going to become tangent 3.5 degrees equals y tangent 9 degrees over 13 plus y. I'm going to multiply both sides of the equation by the expression 13 plus y. So I'm going to have 13 plus y times tangent 3.5 degrees is equal to y tangent 9. And then I'm going to distribute tangent 3.5 on the left-hand side. So 13 times tangent 3.5 degrees plus y tangent 3.5 degrees is equal to y tangent 9 degrees. And I want to isolate y, so I'm going to put both terms that have y in them on the same side of the equation. So I'm going to subtract y tangent 3.5 from both sides, and I'm going to have 13 tangent 3.5 degrees is equal to y tangent 9 degrees minus y tangent 3.5 degrees. To isolate y, I need to factor out y on the right-hand side. So I'm going to get y times the quantity tangent 9 degrees minus tangent 3.5 degrees. And then I'm going to divide both sides of the equation by tangent 9 degrees minus tangent 3.5 degrees. Remember, that's just a constant. Tangent 9 degrees minus tangent 3.5 degrees. And if you punch all that into your calculator, you will find that y is equal to 13 tangent 5 degrees divided by the quantity tangent 9 plus minus tangent 3.5 is actually equal to 8.18 miles. So this is 8.18 miles. So that's up here, 8.18 miles. But we really want to solve for x, which was what was asked for, which is the height of the mountain. So x is equal to y times tangent 9 degrees from this expression up here. So x is equal to 8.18 miles times tangent 9 degrees. And if you enter that in your calculator, you will find out that x is equal to 1.3 miles. So that's the height of the mountain.